Welcome to Echo 204, Study Session 2, the firm's behavior, revenue, cost, and profit functions. The total revenue function. If a demand function assumes P equals K minus AQ, being a relationship between the price and quantity demanded, then total revenue equals P times Q, which equals K minus AQ in bracket times Q. Therefore, total revenue equals KQ minus AQ squared. The total revenue function here is a second degree polynomial and the curve is curvilinear. In general, linear demand functions give rise to collinear total revenue functions. Linear demand functions give rise to curvilinear total revenue function. Profit function. If the firm's total cost function takes the form TC equals F plus BQ, where F equals fixed costs and B equals variable cost per unit, then TR minus TC gives a profit function in terms of Q, that is F of Q. If we denote profit by pi, we can have profit equals TR minus TQ, which equals KQ minus AQ squared minus F plus BQ in bracket. Therefore, profit equals KQ minus AQ squared minus F minus BQ, which we can further express as pi equals minus AQ squared plus K minus B bracket of Q minus F. The profit function is also a curvilinear function, that is a second degree polynomial. Given this background, it is possible to find the quantity of goods that should be produced to satisfy the level of profit that the producer wants to attain at any point in time. Assume that the parameter K, F, A, and B takes the values 18, 50, 1, and 3 respectively. That is, the demand function is P equals 18 minus Q, and the total cost function is TC equals 50 plus 3Q. TR equals P times Q, which equals 18Q minus Q squared. TC equals 50 plus 3Q. Pi equals minus Q squared plus 18 minus 3 in bracket times Q minus 50. Pi equals minus Q squared plus 15Q minus 50. Let us now solve for Q at different profit levels. E.g., at what level of output would a firm break even? That is, a point where profit is equal to 0. If pi equals 0, then minus Q squared plus 15Q minus 50 equals 0. Q squared minus 15Q plus 50 equals 0. Factorize to solve for Q. Q minus 5 in bracket, Q minus 10 in bracket equals 0. Q minus 5 equals 0, and therefore Q equals 5, or Q minus 10 equals 0, and then Q equals 10. It is also possible to find the level of output Q at which profit is equal to, say, 6. If pi equals 6, then minus Q squared plus 15Q minus 50 equals 6. Q squared minus 15Q plus 50 equals minus 6. Q squared minus 15Q plus 50 plus 6 equals 0. Q squared minus 15Q plus 56 equals 0. Factorize the equation. Then we have Q minus 7 in bracket, Q minus 8 in bracket equals 0. Therefore Q equals 7 or Q equals 8. Example 2. Suppose the demand function of a firm is given by Q plus 7 minus 20 equals 0 and its cost TC equals 48 minus 4Q equals 0. Find the largest Q it can produce consistently with A. breaking even, B. making a profit of 12 naira, C. making a loss of 20 naira. Solution: P equals 20 minus Q, thus TR equals P times Q, which equals 20Q minus Q squared. TC equals 4Q plus 48. Profit function: pi equals TR minus TC, which equals 20Q minus Q squared minus 4Q minus 48, which equals minus Q squared plus 16Q minus 48. A. When pi equals 0, minus Q squared plus 16Q minus 48 equals 0. Q squared minus 16Q plus 48 equals 0. Q minus 4 in bracket, Q minus 12 in bracket equals 0. The largest quantity for breaking even is Q equals 12. When profit equals 12, minus Q squared plus 16Q minus 48 equals 12. Q squared minus 16Q plus 48 equals minus 12. Q squared minus 16Q plus 48 plus 12 equals 0. Q squared minus 16Q plus 60 equals 0. Q minus 6 in bracket times Q minus 10 in bracket equals 0. Q equals 6 or Q equals 10. The largest quantity for making a profit of 12 naira is quantity 10. C. Pi equals minus 20. Minus Q squared plus 16Q minus 48 equals minus 20. Q squared minus 16Q plus 48 equals 20. Q squared minus 16Q plus 48 minus 20 equals 0. Q squared minus 16Q plus 28 equals 0. Q minus 2 bracket times Q minus 14 bracket equals 10. The largest level of output consistent with making a loss of 20 naira is Q equals 14. This is the end of study session 2. Thanks for listening.